Hi everyone. So today we'll be doing another virtual tutorial. So actually today we're going to be covering chi-squared, which is an analysis that we only do when we're looking for uh, a relationship between two nominal or categorical variables. Okay. So for this tutorial we're going to be looking at gender. So either if you're male or female, and the frequency in which you have access to internet. Okay, and so here in this variable, if you turn to your questionnaire, it is the first question here, Q1A new. We can see that there are about 9 categories that people can fall into, and so we're looking at the relationship between whether you're male or female and the frequency in which you access the internet for any purpose. Okay. So please open your data sets, and then we're going to be beginning the preliminary analyses. So this is kind of a step that we take before we go into our full-blown analysis to really see any kind of patterns in the data before we run the statistical analysis. So first, we're actually going to start off with some of the assumptions of chi-squared. So if you just scroll down here, we'll skip to this part here and then go back to the beginning of the lab. So the first thing I want to point out is all cells should have an expected count greater or equal to 5. So that means if you go back to the questionnaire here, it means that there needs to be at least 5 people in the data set that fall under each category of these 9 categories, at least 5. And because we also have another variable, which is whether you're male or female, we need to have 5 people in that category as well falling under these categories. So to make that more concrete, we would need at least 5 people who are male who access the internet more than 10 times a day. And then we would also need at least 5 people who are female who access the internet more than 10 times a day. Okay, and that would follow the same kind of pattern of understanding and logic for the other categories of this variable. So we'll see if we make that assumption when we run our preliminary analysis and get the program to count the frequency in which people fall under each category. So the second one is both variables have to be categorical. In this case, if we look at in the data set here, if we go into variable view, we can see that gender is nominal, so we're good for that assumption. And then internet use, however, is ordinal. Okay, so we may need to switch this at some point to nominal for this to pass the assumption, and we'll be doing a method to recode our categories so that can occur. But ordinal is also technically categorical as well because it's not a scale variable. So we're okay with ordinal and nominal, and then we will be switching this variable throughout the lab to look at how we can change some of the categorization that's happening. There is independence of observations, so that means that each person in the data set can only contribute one data, okay? And so what that means is that, for example, if you were a male and you access the internet more than 10 times a day, you're still contributing to one frequency count, okay? So you have to contribute 1 to 1 level of the gender variable and contribute 1 to 1 level of the other variable. You can't be represented in the other categories at the same time. So that will become more concrete as we look at how the data is set up. And the last one, the data has to be cross-sectional, which means that the data is correlational only. So that means that we're not doing any type of manipulation to change the outcome of our dependent variable, And it also means that the data that we see in this data set only represents a snapshot, so one time point of how people are responding, which is the case in this data, so we're okay. Okay, so first off, let's list our hypotheses and identify which variables independent and dependent, and then the specific level of measurement for each of them. So our hypotheses are based on what the test is doing, okay? In a chi-square test of independence, which is what we're running, the test is trying to see if there's a relationship between the two variables, or if each variable is independent from each other, so they don't have any relationship, they don't influence each other, etc. Okay? So the null hypothesis is that they are independent. So gender is not predictive of the frequency you use internet. So that would be the null hypothesis. The alternative hypothesis is that they aren't independent, they're actually related, such that being one particular gender might be more predictive of higher access to internet or frequency of using internet, whereas the other gender is related to a lower frequency of internet use. So that would be your null and your alternative hypotheses for this test. Which is independent and dependent. So your independent is kind of the variable that you really think is going to be predictive of the change in the other one, okay? So in this case, it makes more sense if we say that depending on your gender, that predicts the frequency of internet use, versus saying that the frequency of internet use predicts your gender, okay? So it just makes more sense that we're using gender as a very static, inflexible kind of prediction of internet use here. So gender would be the independent, which is influencing the frequency in which you use internet, which is the dependent variable. The level of measurement is listed here in variable view, so you can kind of see that this is ordinal and that gender is nominal. Okay, so let's get to the preliminary analysis here. So what we're going to do is ask the program to basically generate some frequencies for us and to count how many people fall under each kind of category collapsed together. And we're going to be just looking at frequency counts. So we won't be running the test to see if they're independent or related yet. We're just going to be looking at the frequency counts and kind of looking at some patterns. So the first step is to go into Analyze, Descriptive Statistics, and Crosstabs. So we're going to go into Analyze, Descriptive Statistics, and Crosstabs. And here you're being asked to move over your variables. So which one's going to be the column and which one's going to be the row. So we're going to put gender into the row. And then we're going to put access to internet into the columns. Okay, so we don't have to click off any of these options here yet, because this is already going to create the crosstab for us, the columns and rows, and count the frequency in which people fall under these categories. So let's click OK. So here in your output, one second here. Let's go full screen. So the first box here labeled Case Processing Summary basically just tells you some basic information about how many people answer these questions in your database, okay? So there are 2,531, okay? And if we go down to this table here, this is what we call a contingency table. We can see that male and female are represented down here, and then the frequency of internet use here, okay? So here we can see that this is how many males reported that they access the internet more than 10 times a day, so 566. This is how many females accessed it more than 10 times a day, 547. So if you keep going down the rows and follow the row, you're looking at males across that other level of the categorical variable, whereas down here you're seeing the same thing for females, okay? Now, if you kind of just look at the frequency counts here, we can kind of see that the frequencies are kind of similar. So we can see that, okay, in this category here, more than 10 times a day, males are more likely to answer that they access it more than 10 times a day. However, if you look at the patterns throughout the other levels of that variable, we're not seeing a huge difference. So it's also possible that it doesn't matter what gender you are, you're just as likely to access it very frequently or the least frequently. So before we make any types of generalizations, we're going to have to run our chi-squared analysis. So that should be all you need to answer questions for 3D right here. So you'll be recording the frequencies that we saw in that contingency table. And you can report some general patterns that you see. So now another method of kind of looking at patterns but not running the analysis, we can, instead of looking at frequencies, we can actually compare the percentages. So we can look at this pattern in a different way, which might be easier for us to conceptualize if there is a relationship or not. So we're going to use the same drop tab there for crosstabs as we were. Except now we're going to ask for percentages instead of frequencies. So analyze, descriptive statistics, crosstabs. If you click on cells here, now you'll see the option of percentages. So we're going to click off percentages for row. Click continue and OK. So if we scroll down, you should see that your contingency table has looks slightly different. You'll still see the frequencies at the top, the count, but then beneath it you'll start to see the percentage breakdown. Okay, and so we're kind of seeing the same pattern again, where the percentages are very close because the counts were very close. So it doesn't give us too much more information about the pattern, but it could be useful for you to report or look at instead of the frequency counts. So now she would like you to paste that new contingency table into your Word and interpret the different levels of frequency that you see, and kind of interpret this table very briefly in the same way that you interpreted the frequency count table. So now we're ready to actually conduct our chi-square test, which will tell us if these variables are related or if they're completely independent and have no influence on each other. Okay. So now we're going to go back into the same drop-down tab, crosstabs, but this time we're going to select statistics, and then we're going to actually analyze the statistical analysis. So I'm just going to minimize this here. Okay. So now you're going to go into this statistics box, and we're going to click off chi-squared, which will give us our chi-squared value and our p-value to determine if they are independent or related. And then we're also going to ask for Cramer's V, which is an effect size. So it'll tell us the magnitude of the relationship if there is one. So click continue. In the cells box, we can actually, you want to keep rows in the percentage still clicked off, but you're also going to want to click off on expected. So observe should already be clicked off for you. Click continue and okay. Okay. So you'll always see this case processing summary. This is kind of like a default box, but we can ignore that because we're more interested in the statistics here. And you can ignore the contingency table as well. So what we're really interested in looking at here is this chi-square test box and the symmetric measures, okay? So let's start off on analyzing our statistics. So the line that you're really interested in looking at in this box is the Pearson chi-squared, okay? So this whole row of information is what we're really interpreting. So this is the chi value, okay? And this is the degrees of freedom. So in order to know if this chi value is statistically significant, we want to look at the p-value of this test. And so this is actually your p-value. So our cutoff point is 0.05. So if it's 0.05 and below, we know that it's statistically significant, which means that the variables are related and they're not independent, okay? But in this case, this is above our 0.05 cutoff, which means it's not statistically significant, which means that these two variables don't influence each other, okay? So that means it doesn't matter what gender you are, you're just as likely to access the internet very frequently or very infrequently, okay? So our p-value is 0.91. So now that we know this, this box is telling us, this Cramer's V line specifically here, is our effect size. So if there was a relationship between these two variables, this would tell us the magnitude. How big is that relationship? Because sometimes when we have really big data sets, we're very prone to get a statistical significance, but it doesn't mean much if the relationship is very small, because that means it might not always appear over and over again. If the relationship is big, that means it'll keep appearing throughout time and that these things are really related to each other, okay? So Cramer's V has a value of 0.036. Now if we go into how to interpret this, Cohen gave us some cutoff values, which basically said that if you have a value of 0.10 and below, the relationship is small or weak. If it's 0.30, it's moderate. And if it's 0.50 and above, then that means it's large, okay? So in this case, we would say that this falls under the 0.10 and below, which means that this relationship is small or very weak, okay? So that takes care of this question. Now here, determine whether all expected counts are 5 or higher. So if we look under this box here, we can see that when we run statistical analysis, this program is really good at telling us, maybe we didn't meet the assumption for this test, okay? And so it's telling us that 4 cells have an expected count less than 5. So one of our assumptions is that the minimum expected count has to be at least 5. So how can we see what this means, okay? So if we look into our counts here, we can see that, okay, this category in male is lower than 5. There's only 2. And same with female, there's only 2, okay? And then here we have the case of female once a week, there's a 3. Once a week for males, there's a 4, okay? And all of the other ones are above 5. So that's where this is coming from. Okay. So how do we fix this problem if we come into this problem but still want to run a chi-square test? So to meet our assumptions, what we can do is take away some of the categories that have a low count so that we don't take them away completely. We collapse them into other categories that have counts. And we rename the category so that now the collapsed category represents both categories, okay? So what we're going to do is collapse the 7 and 8, which represents here 7 and 8, so that they're one variable together. And we're going to rename that variable to represent both of these types of categories. So we're going to rename it weekly or less, okay? And then hopefully our count meets the minimum and we can rerun the statistical analysis to really see if those variables are related or not. So in order to do this, we're going to go into a new drop-down tab that we haven't used before. We're going to go into transform. And we're going to recode because we're changing the 7 to an 8. Okay, so everyone that fall under category 7 before is now going to be collapsed with everyone who's in category 8. And then we're going to rename category 8 to weekly or less. So we're going to recode into the same variable because we still want to use this variable. So we're going to go into recode and then click on that and then click on old and new values. So this is where we have to tell the program which values are we keeping the same and which values are changing, okay? So we're only changing the 7 to an 8, but we have to tell the program the 1 is going to still stay a 1, a 2 is going to still stay a 2, etc., okay? So just make sure that you are doing this correctly. 2 is a 2, oops. 3 is a 3, 4 is a 4, 5 is a 5, 6 is 6, and now the 7 is going to become an 8, so 7 will no longer exist. 8 will still be an 8, so we're collapsing both groups together. And then we have 998, so don't forget about that category as well. So 998 still stays 998. 998 still stays 998. Okay. And continue. Alright. Then click OK. Now it's going to recode. You should see this in your output. This is how you can fact check yourself if you did it correctly. Okay. So it says recode. So now we have to go and change the label because we renamed. We're going to revamp what really it means to be in category 8. Okay. So let's go into variable view and find our variable right here. And we're going to go into values. Click on here. So all we need to change is the 7 here. So we're actually going to remove 7 because the 7 in the data doesn't exist anymore because the 7 is now an 8. So click remove. And click on 8, okay? You can keep the value there because we recoded the 7 to an 8, but we're going to change the title to weekly or less. So weekly or less. And click OK. Right. And it should look like that. Perfect. Now if you want, you can change this to nominal. It could stay ordinal. It's really up to you. Okay. So that should have gotten you through all of here. And now she would like you to change the decimal to 0 and make sure you have the correct level of measurement. Okay, so we can keep that as ordinal. That's fine, and change the decimal place. So the decimal place is right here. Oops, sorry. And it's still at 0, so that's fine. Okay. All right. Now, let's rerun the crosstab or chi-square test now that the assumption is now met that we have the minimum of 5. Okay, so now we're just going to rerun exactly what we ran before and interpret it in the same exact way. So, analyze, descriptives, crosstabs. We're actually going to click reset so that the program can reset the recoded variable. Okay, so click reset. Put in gender in the row, and then here is your newly recoded variable here. Click on statistics, chi-squared, Cramer's V. In cells, we want the row percentage clicked off, and the expected counts, and then click OK. All right. So now here's your new contingency table, which you would like you to paste into your Word format. And if we see the counts, we've actually fixed the problem. Okay, so there's a minimum of 5 in each of these categories now. So we've met the assumption and fixed the problem, which is great. Now if you look down to our chi-square test right here, our degrees of freedom went down because we actually got rid of one of the categories. Okay. The chi-squared value is 3.249. Is that statistically significant? Here's the p-value, and it's not because it's still above 0.05. So gender is still not related and is completely independent from frequency of internet use. Okay. And if we look at our Cramer's V, we see that the relationship is still small/weak. Okay, so our analysis didn't really change. The p-value changed, the chi-squared value changed, the Cramer's V did not change. Okay, so we can conclude that they're completely independent from each other. And so with these results, because the null hypothesis is that they're independent from each other, it means that we are going to accept the null hypothesis because they're not related. Okay, if they were related, the p-value would be 0.05 or smaller. So we can actually accept the null hypothesis. And yeah, so that's actually all you really need to know for this lab. Save your downloaded SPSS file and also send me the Word file. If the submission portal's not open, just send it to me as a group with all the last names on the documents to my personal email.